This is what you
Yeah, this
submitted.
one. Yeah.
So now you see, I gave you question number. It's written 1, 2, 3. I didn't give you 4. And what was the fourth question? Is the gravity a property of Earth only? And you gave the answer yes. The answer would be no. Gravity
Oh,
is the property of Earth. Why? Because you must have seen that the planets revolve around the sun. Now, why do planets revolve around the sun? Because there is some sort of gravitational force. 1 second.
mm,
Hmm. There is some sort of gravitational force with which sun is pulling all the different planets. That is why they are revolving in an orbit. Okay, so gravitational
yeah.
force is not just a property of Earth. Okay,
Mm.
uh, and you left the last question. You didn't do it.
Yeah, I didn't know the answer.
See, it's not that difficult. In a circuit shown in the figure, when the key is closed, this is the key. This is the key, right? This.
Yeah, yeah.
The compass needle placed in the matchbox deflects. The compass needle deflects. Name the force which causes the deflection. So what I wrote, I have written key. You just see the diagram and tell what kind of force is acting here. So you see there is a bulb, there is a socket, and there is a battery.
No, I didn't understand the needle and the matchbox thing because is the black thing a matchbox?
Yeah, that is a matchbox. You
Oh,
didn't understand the diagram. It was just asking name the force which causes the deflection. So what we saw in the last lecture, that if the ions are involved, so we can see here minus and plus are there. That is electrostatic force, right?
yeah.
I gave you some examples of when you charge a comb by rubbing it on your clothes, and then your hair rises in the air. So charges develop on it. Similarly, their charges develop, and here charges are already present. A negative and a positive are present. So it would be an electrostatic force of attraction, right?
Yeah.
Hmm. So this one is done. And then, yeah, this is the only homework left. Hmm. So we were on the topic force. Can you give me some examples of contact forces and some example of non-contact forces without seeing in your copy?
Yeah. Contact forces, muscular force, and frictional force.
One more example.
Uh, Gravitational force. No,
Gravitational
right?
force. Oh, wow. Wow, Rohan. Gravitational force is a contact force?
E- No, I don't think so.
See, now you see your notes. You didn't revise, I feel so.
Um,
See here, see here. Now don't scroll the copy. Non-contact forces, we have written only 3 examples. Magnetic force, electrostatic force, and gravitational force. Even the diagrams are given.
yeah.
Okay. And
Mm.
uh, contact forces are, you can simply say uh, push, pull, kick, friction, muscular force. So these are all example of contact forces, right?
Mm.
Okay, got it. Uh, okay, what else?
What about muscular force? I told like two forces. You told one more, right?
Yeah, I gave you example, muscular force, friction force, push, pull, kick are examples of all contact forces.
Oh, okay.
See, see here, contact force is what we have written: carrying, pulling, pushing, friction, muscular force. These are all examples of contact forces. Okay,
Yeah.
now tell me, um, force we saw on the last lecture, that force is mass into acceleration, right?
Yeah.
If force is in Newton, then mass would be in
Mass would be in kg.
yeah, and acceleration would be in
Um, meter square.
yes. And if this force is in Dian, then this kg would be gram, and this meter square would be centimeter square.
Ah, okay.
Okay.
Yeah.
Uh, yeah. Also, Rohan, tell me, if the mass of a body is 2 kg, what is the weight of that body on Earth? You didn't revise the lecture.
Uh, no, I forgot.
Rohan, things will not work like this. You are having an exam in a couple of days.
Yeah.
So, for weight, we have a formula. W is equals to mg. Repeated.
The
Weight is equals to,
yeah, mg.
what is mg? What is m?
M is wait, I remember this. Wait, G is acceleration due to gravity, but M, I forgot M.
Oh my God. Are you serious? M is the mass. How can you forget that?
Oh, mass. Yeah.
Without mass, weight doesn't exist.
Oh, yeah.
For example, there is something it doesn't have a mass. So 0 into g. Okay, what is the value of g?
What is the value of what? G.
Acceleration of gravity. What is the value of this g?
Oh, 10.
10 or
9.8.
9.8. Value?
Value? Wait, what?
What is the value of g? What is the unit of g?
Oh, I don't know.
Okay. So it is meter per second square.
Oh, okay.
So we write 9.8 or 10 uh, meter per second square. Where you written g, right? So in front, write the dimension also. It is meter per second square.
Okay.
Hmm. Done.
Yeah.
Yeah. So we saw gravitational force, electrostatic force. Um, the similar charges repel or attract each other.
Um, repel.
And the different charges.
Attract.
Okay. Hmm. Nuclear force also we have seen. So last slide that we were seeing was pressure. So what is pressure? Force acting per unit area is known as pressure. Let's suppose this is a cardboard.
Yeah.
This is a nail, an iron nail, and this is your thumb. So what you do if you want to press this downward, this nail into the cardboard, what you will do? Simply you will apply pressure on that nail. So if someone
Yeah.
asks us what is that pressure which is applying, so basically when you use your thumb, you have a certain force, right? So you
Yeah.
apply that force. So okay, now let's see. Look here. So this thumb has a certain force F, and this nail, the head of the nail will have some area, right? And
Yeah.
force which you apply on this area is called pressure. So we say pressure is equals to force we apply upon area. This is the definition. Force acting per unit area is known as pressure. So pressure is also force upon area. And the unit of pressure is SI unit,
Pressure Pascal.
Pascal. Yeah. Hmm.
Yeah, done.
Let's solve some problems for our book.
Okay.
Uh, some pressure. So we saw what is force, a push or pull, right?
Yeah.
Hmm. Then this is done. Force are due to interaction. Forces are due to interaction. Are all forces due to interaction?
No.
Okay. And the forces which are not due to interactions are called?
Non-contact force.
Yeah. Uh, also saw this, right? When forces are applied on an object in the same direction, they add.
Yeah, yeah.
They add in different direction, the forces subtract, right?
Hmm. Yeah.
Okay. Um, okay, solve one problem quick first. So if talking about direction, this is north, south, this is east, and this is west, right? And there is a
Hmm.
box kept on the floor.
Yeah.
7.5 Newton is applied here, 3 Newton is applied here, 3.5 Newton is applied here, 1 Newton is applied here, and 2 Newton is applied here. Tell me where will the box move?
Okay. So, um, it'll move a little. It'll mostly move up.
Sorry, repeat your answer.
It'll move up.
It will move up. Why?
because the arrows facing up get divided because it's going in the same direction, and the arrows
I
facing
did.
right.
We only talked
What?
about forces getting add or subtracted. When did we say it divides?
I didn't say divide.
Okay, tell me the answer final. It will move up, nowhere else.
No, 3 Newton will move up,
3 Newton up and
and 1.5 will move to the
1.5. Really, 1.5?
wait. Oh, one.
Yeah, 1.
One will move to the left.
Don't say right, left. I've given you directions, north, south, east, west. Tell me.
Oh, okay. The 1 Newton will go to the west, and
Hmm.
the 3 Newton will go to north.
Yeah, very good. I hope you will be able to solve every question now in exam.
Okay.
Magnitude, we have seen what is magnitude, the value, and the direction. Both are required for force because force is a vector quantity, right? A
Yeah,
force can change. A force can change the uh, state of a motion. Give me one example.
of course.
Also, you wrote. I gave you one question that in assignment. What are the two states of motion? You wrote what? What was the answer you wrote?
Um,
No, don't see your assignment. Don't see your assignment without seeing assignment. What answer you wrote for the states of motion?
Static and dynamic.
You saw that answer from book.
Um,
Be honest with me.
no, I asked my mom.
Hmm. Mom won't go in the exam to write your answers, right?
But I didn't know the answer for that
We
because
discussed that. That is why I was shocked to see the answer because I didn't mention static and dynamic word, but I mentioned some other words for states of motion. I wrote whether the body is at rest or the body is in motion. Rest is called static and
yeah.
motion is called dynamic. So these are very heavy words, which are like
Oh,
only teacher or book uses it. So that is why I was shocked to see where did you write that answer from. Need
okay.
not to write this hi-fi. You can simply say at rest or at motion. Okay.
Oh, okay.
Okay. It's a very simple term. You can use that. It is also correct. Static
Hmm.
and dynamic is a very hi-fi word. That is why I was shocked to see. Okay. A
Like, can
force
I
can,
still use like for exam and stuff?
yeah, definitely you can use. It's up to you.
Okay.
A force can change the state of motion, which means, example, give me an example. Fast.
Um,
What is the state of motion we just discussed? At rest and at motion, there are two states of motion.
yeah. So, if an object is at rest, if you like push it or yeah, if you push it, it changes its state of motion, and it like moves, right?
Yeah. And similarly, if an object is moving, we apply brake. For example, a car is moving, we apply brake, and brake is a sort of force. So it changes the motion. It from motion it becomes to rest. Okay. From dynamic it
Yeah.
becomes static. That is, a force can change the state of motion.
Hmm.
Also, force can change. Second one, force can change the shape of an object. Give me an example.
Um, uh, uh, making chapati.
Yeah, chapati. No, not making chapati. Making dough.
No, like, yeah, dough.
Hmm.
Dough have to use the muscular force to change the shape.
That is called kneading the dough. Not
Kneading.
making the dough, it's called kneading the dough. Yeah.
Okay.
Uh,
Huh? Huh? Can you tell me what force, like what type of force the rocket is, like from up to down?
where?
Huh?
What did you say? Repeat. What
No,
kind of
I
force?
want to know what type of force like a rocket is, like when it's being burst to go up.
So
Yeah, what type of
when a rocket is going up, so you must be knowing there are atmospheric layers in the atmosphere, right? If you must
yeah.
be knowing the names, there are stratosphere, troposphere, ionosphere, mesosphere, and exosphere. So what happens when the rocket is expelled or projected from the ground? So there is a range up till where gravity acts only up to a certain range. So what happens? That is why you must have seen there is a lot of fire downside the rocket. That is the it uses a fuel and it reaches up to that position because at the stage, for example, let's suppose at this stage till here from the ground, gravity is there. So even if the rocket reaches here and the fuel gets empty, what would happen? It would be under the effect of gravity, it would come down. So that fuel
Yeah.
is used to make the rocket reach from ground to pass this level. Once this level is passed, now what happens? Since the rocket has reached out of the zone of gravity, now it becomes it is free of the under the motion of gravity. And what will happen then? This is let's suppose this is Earth. So rocket reached up till this position, gravity was
It
there.
just floats this.
After reaching here, after it is out of the reach of gravity, it will start to orbit around that planet.
Hmm.
That is what satellites do. The telecommunication satellites, they reach up to a certain level through the help of rockets. Then, after they are out of the reach of gravity, what happens that they start orbiting around the Earth and
Hmm.
supplying signals all around the world. That is how it happens.
Hmm.
Muscular forces we have seen, friction also we have seen, non-contact forces, magnetic force we have seen. Um, Electrostatic force due to electrons and
What?
electrostatic force due to electrons and you know what are electrons?
Uh, yeah, it's like one of the things which make up a atom.
Yeah, so there are electrons which are negative, then there are protons which are positive. So electrostatic force is the force which is due to electrons or protons. It can be
Okay.
electron proton or proton proton or electron electron. Okay.
Okay.
Hmm. Pressure. Pressure is also force upon the area on which it is active. We have seen this. Okay. Let's see some examples. See, here also they have explained the same example. Pushing a nail into the wooden plank. So what you do, you
Yeah.
apply pressure on it. A porter carrying heavy load. Now, how does it changes the force? Why porter place a
Uh,
piece of cloth on their heads? Have you seen a porter carrying load of?
yeah. Yeah. I know.
So they carry heavy to carry heavy loads. By doing this, they increase the area of contact of the load with their head, so the pressure on their head is reduced. Now we have
Yeah.
seen the formula: pressure is equals to force upon area, right?
Yeah.
So this means, okay, for a moment, hide area. So what do you see? That pressure is equals to area. If you increase the force, sorry, pressure is equals to force. So if you increase the force, pressure will increase, right?
Yeah.
Because both are equal. Forget area for a second. Pressure is equals
Yeah.
to
Yeah.
force. If you increase the force, pressure will increase, or if you increase the pressure, force will increase. For example, let's take the nail. You are pressing the nail with your thumb. So you feel that it is not going inside. So what you do? You apply more force. And by applying more force, more pressure is applied, right? So why is
Mm.
that? Because pressure is equals to is equals to force. So if you increase the force, pressure will increase, or you increase the pressure, force will increase. But now you see, pressure is not equal to area. Pressure is equals to, so from here we can say that pressure is equals to force. But pressure is not equals to area. Pressure is equals to 1 upon area.
Yeah.
This means if you increase this, this will increase. If you decrease this will decrease. But here opposite happens. If you increase the pressure, the area will.
Uh,
If you
wait.
increase the area, the pressure will.
If I increase the area, the pressure will decrease.
Yeah, because they are. This is called inversely proportional. Have you heard this word?
Huh? No.
This is called inversely proportional. This is called directly proportional. This is direct
Oh.
equal. This is equal. So this is called direct proportion. This is called inverse proportion because it is opposite. So if you
Okay.
increase this, this will increase. If you decrease this will increase. Okay. Here opposite happens. If you increase the area, pressure will decrease. And if you decrease the pressure, area will increase. So opposite it is.
Okay.
Write it.
Yeah, I wrote it.
Okay. Now write if force, this means increase. Okay. Up arrow means increase. If force increases, so pressure will increase. If force is decreased, then pressure will also decrease.
Okay.
You understand the arrow, right? Up arrow means
Yeah.
increase and
Yeah.
down arrow means decrease.
Yes.
Now you tell me for area. If I increase the area, pressure will.
Decrease.
Yes. And the last one, if I decrease the area, pressure will.
Increase.
Yeah.
Okay, done.
Hmm. Now you tell me. Um, I make you stand on a nail, an iron nail. Will you be able to stand on the iron nail?
A what?
Uh, if I make you stand on an iron nail, will you be able to?
No.
Why? Because if this is the iron nail, let's suppose the area is very less,
Yeah.
very tiny.
Yeah.
So if the area is very less, the pressure is very
More.
big. So it directly goes into the your leg. And let's suppose
Yeah.
make you stand on a wooden plank, on a wooden board. So the area is
Yeah.
big, the pressure would be less. You are very comfortable standing on a wooden board because of it. So it's all relation of area with pressure. This
Mm.
is what the example was about the porter.
Okay.
Yeah. So it says that. So you must have seen that the porter, if I zoom this image, so you're seeing here that the porter has a cloth on his head. This.
Ah, yeah.
So why do they wear it? Maybe some of because of fashion sense.
Because of what?
Is that a fashion trend that they wear it for?
No, it's to reduce the pressure as he's carrying a load of weight on top of his head.
How will the pressure decrease?
Because there is more area of contact
Yeah, if
compared to
this
your
is the
head.
head and you keep some slab on it, so area is less. Now, if you tie a cloth around your head, now area increases. So if area
Yeah,
increases, pressure will decrease. Okay.
yeah.
Hmm. Then what we have? Pressure exerted by liquids and gases. There's some activity. Hmm. Can now you see that liquid exerts pressure on the wall of container. So let's suppose this is a bottle kept on a table. So the water inside, will it exert any pressure on the wall of the uh, bottle?
Um, no.
Why?
Mm,
Why
I don't
no?
understand.
I'm saying water is there inside the bottle, right?
Yeah.
Will the water apply any pressure on the bottle?
No, it's not that
Why?
way. Because the depth of the water is less.
There is no relation with depth. There is, you tell me, there is contact between water and bottle, right? The
Yeah,
surface of the bottle and the water are in contact from inside. So when they are in contact, there would be some sort of force acting between the water and the bottle container. That is what the statement here says, that a liquid, so water is basically a liquid. A liquid exerts pressure on the wall of the container. So a liquid exerts pressure on the wall of the container. Now, if you make a cut in the bottle and you apply a balloon, so what would happen? The balloon would inflate, right? After some amount of
yeah,
time, because the water with a pressure, with a certain pressure, it would start going inside the balloon, and the balloon would soon inflate and grow
yeah.
bigger in size. Yeah. Now this was about liquid. Now, do gases also exert a pressure?
Gas,
We have seen for solids, we have seen for liquids, now coming gases.
atmospheric pressure.
Yeah, atmospheric pressure. So that is also a thing, and you must have seen there are some. If you must have seen pressure cooker, so there is also water vapors and air inside it. So when you open it, there is a lot of pressure inside it.
Yeah.
So gases also exert pressure.
Mm.
Let's try to solve some questions. Yeah, atmospheric pressure. This was left to see. Um, you know that there is air all around us, and the envelope of air is called atmosphere, which I just told you. There are certain levels of atmosphere, and atmosphere is a thick layer of air, and there are certain levels of it, like stratosphere, mesosphere, ionosphere, exosphere, depending upon the range. As up you go, the level will change. Okay. The atmospheric air
Yeah,
extends up to many kilometers, which we have seen, above the surface of the Earth. The pressure exerted by air is known as atmospheric pressure. So, what is atmospheric pressure? The pressure which is exerted by air is called atmospheric pressure. You want to write it down in
yeah.
your copy?
Huh?
You want to write it down in your copy?
Yeah.
Write it down. The pressure exerted by the air is called atmospheric pressure.
Uh,
Then you can also write solids, liquids, and gas. All three exerts pressure.
okay. Yeah, done.
Hmm. Now look at the keywords. Tell me what is atmospheric pressure.
Atmosphere. The pressure exerted by the air is known as atmospheric pressure.
Hmm. And also we know that pressure is equals to force upon area, right? So
Yeah.
talking about atmospheric pressure. So how can we define it as in terms of force and area? The force exerted by the gravity. See, this is also given here. The atmospheric pressure is if we have to define it in terms of force and area, because pressure is equals to force upon area. So we can say that atmospheric pressure is the force of the gravity. It is the force of gravity on air in a column of unit area. Unit area on an air column. This is an air column. So if you see this way, and this is the unit area. So the force, if this is the column and this is a unit area, so the force that gravity will exert on this area, this particular area, that is called atmospheric pressure. You getting it? There is a
Uh,
column of air inside it. Okay. Let's suppose a gas column. Column means basically take a glass cylinder. Okay.
yeah, yeah.
This is the open area of that cylinder. So what happens is that since This is the area, open area, where this air will come in contact with gravity. So here gravity is downward. So here gravity will exert a force, gravitational force, on this particular area, and that is called atmospheric pressure.
Hmm.
The force of gravity on the air in a column of unit area is called atmospheric pressure. You can also write this definition, but it's a difficult one. The first one is simple and that works. Then comes contact forces.
Hmm?
Contact forces.
Contact force, um, it's a type of force where you have to make um, direct contact with the object.
Okay.
Yeah,
Electricity.
electrostatic force. It's a type of non-contact force
Yeah.
where I don't know
Where
like how to define.
where charges.
Huh?
Electrostatic force is a type of non-contact force where charges.
Where
Now you
charges like
where charges create this force.
create. Oh, okay. The
Yeah.
charges create this. Yeah.
Force we know, friction. Okay, that's all. Let's see. Let's see the key points. Force can be a push or pull. We have seen this. A force arises due to interaction between two objects. Force has magnitude as well as direction. So why, which quantity would it be? Force has a magnitude and has a direction both. So it would be a,
Um, Vector.
yeah, a change in the speed of an object or the direction of its motion both implies a change in the state of motion, right? Change in the speed or change in the direction or change in the shape of that object, which means there is a state change in the state. A force acting on an object may cause a change in its state of motion or a change in its shape, right?
Yeah.
Hmm. A force can act on an object with or without being in contact with it. True. Force per unit is called pressure. Liquids and gases exert pressure on the walls of their container. The pressure exerted by air around us is known as atmospheric pressure.
Okay.
Solve the question number one.
Two examples. Uh, Wait. Two examples. Do I need to write it or just tell you?
Just tell me why to write it down.
Okay.
Two examples of situation in which you push or pull to change the state of motion of an object.
So like you have to push a ball for it to move from its rest position.
Tell me for pull.
For a pull,
Don't say push a ball. It doesn't sound very appropriate. You have to kick the ball, not push the ball. So you can say push a box.
push. Oh, okay, box.
Hmm. And for pulling,
Um, can I say like opening a like pulling a door?
yeah, definitely that's a very good example for pulling a door where it changes the state of motion. Earlier the door was at rest, and when you pulled the door, it started moving.
It,
Now, give two examples of situations in which applied force causes a change in the shape of an object. Not giving the answer of needing the door. Some other example.
uh, change its shape. Clay.
Yeah, that can be an answer.
Clay.
What clay? I mean, just clay.
What? No.
It's a proper sentence.
Like we play with clay, so it like
We
if
apply force and
we
the shape of the clay is changed, right?
what?
We apply force and the change and the shape of the clay is changed. That is what you meant to say.
Yeah.
And second example,
Um.
I gave you an example if you remember. Crushing a cardboard box.
Oh yeah. Wait. Wait. Cardboard box.
What?
Wait. Can I say like what is it? Squishing a rubber ball.
That is a different kind of motion. What would happen? The here that says which causes a change in the shape of an object, which means the final result should be a change in the shape. If you squeeze a rubber ball, after you retract your force, what happens? It comes back to its original shape. So the
Oh,
motive is
okay.
not achieved.
Yeah. That
Hmm.
shape.
Hmm. Okay, fill in
Mm.
the blanks in the following statement. To draw water from a well, we have to dash at the rope.
Pull.
Okay, I'll give you this as homework. As you can.
Okay.
There are no numericals. Okay, your mom was saying on the second day that she will manage to get the question paper from the school. Did you manage to get it?
One second. Sir, I'll send you the picture today.
Okay. Now you tell me anywhere, any topic which you were not able to understand in this chapter.
Um,
Any
no, I
you feel
understood
like
everything.
you were not able to grab it 100%.
No, I understood everything actually.
Okay. So shall I give you one question, one numerical to solve?
Yeah.
Okay, great. Let's do it in on notes.
What?
No, wait. Yeah. So you tell me, um, should I give it in the statement form? A ball, there is a ball of mass 3 kg
Yeah.
is thrown with a force of 10 Newton on a wall of area 10 meters square. Find the pressure.
Find the pressure.
Make it 30. The force make it 30.
Oh, okay. Pressure equals 3 PA pascals.
Pressure is equals to 3 PA. That is your answer.
Yeah,
Okay. How did you do it?
I did force equals, I mean, not force, pressure equals force by area.
Okay. So you put force as 30 and area as 10, and you got 3.
Yeah.
You Is that a final answer?
Wait.
Okay, all right, it's correct. I'm just trying to test you.
Okay.
Now, do one more question.
Yeah. Yeah, what?
There is a ball of mass 5 kg. Okay, now I'm just writing the values, and it is hitting on a wall of area 100 centimeter square. Now find the pressure.
Is it the same way?
Yeah,
Huh.
you have to find pressure, and area is 100 centimeter square, and mass is 5 kg. Use your brain. How can you get what you want to? So first of all, how you have to solve such questions? First, see what is asked? Pressure, right?
Yeah.
Now see what is the formula of pressure. Now in that formula, whatever comes, are you given that things? If not, how can you get those things? For example, if you go to make tea, you see you have sugar, you have coffee or milk. So if you don't have milk, what you do? You go to the grocery and get milk. Similarly, see what you need to find pressure. If it isn't there, how can you find that thing? And give me the answer.
Oh. Hmm? Sir, I don't know.
Why don't you know?
I don't understand where to get force from.
You are not wanting to use your brain. It is given in front of you. It is wrapped in some other form. You have to find it. So first, let's look at the screen. Okay. So pressure is asked. So pressure is equals to force upon area. Correct?
Hmm.
Do you have area?
What?
Do you have area?
Yeah, yeah.
Do you have force?
No.
So what is force? Tell me the formula for force.
For force, you have to do uh, pressure
Oh, no, no, no,
into
no.
it.
There no. Force is pressure into area. That is also correct. What is the other formula for force?
I don't know.
You don't know. That won't work if saying I don't know. That won't work. That won't solve the problem. That was the first class we saw. Force is equals to mass into acceleration. How can you forget this?
Wait, area and acceleration is the same thing.
Oh, come on. Area is different, acceleration is different. That is why I'm writing it with
Oh,
small a. That is why I'm writing it with capital A.
okay.
How can area and acceleration be same?
It's not. It's not.
You drive a car, so you know that we say we accelerating the car. So what is acceleration? Increasing the speed is called acceleration. So
Yeah.
some increasing the speed, and other thing is the area. So how can they be same? There is no comparison between both. Okay, now coming to the problem. So we were having area, we were not having force. So we know that force is equals to mass into acceleration. Do we have mass?
Um. Yeah.
How much?
5 kg.
What is the value of A?
A is 100 centimeter.
That is area. I'm talking about acceleration.
Oh.
If it is hitting on the ground, so basically acceleration due to gravity would be working, right? So you can write here 10.
Oh. Why?
If you are hitting the ball on the ground, so if you're dropping the ball on the ground, so this is a ball and it is dropped on the ground. So G will be acting downward, or even if it is thrown with an angle, then also G will be there. So
Oh. Okay.
G is acceleration due to gravity. So acceleration we take 10. So 5 into 10. So force comes 50. Okay. Now
Yeah.
we got force. So now tell me the answer for pressure.
Um. 2.
2. How come you get 2?
It's 2. Yeah.
How 2?
Force divided by
What is
area.
force? What you write force? 50. What you write area?
100.
This will be 2. Now should we start a chapter with maths to see if this is 2? Really, Rohan?
Oh,
50 upon 100 is
wait.
2.
Wait. Wait. One second. One second. Okay, sir, after a bit more calculations, I come to an answer of 1/2.
Whom did you ask?
Huh?
Whom did you ask the answer?
Um,
Look at me. Whom did you ask the answer?
no, I didn't know how to do it. I'm a bit bad at maths, but I seriously get confused in like this kind actually because in 100 table 50 doesn't go right.
Already we are done with our time, but just to, and also math is not, I'm not teaching you maths, but still you can see. So if it would have been 100 upon 50, so 50
Yeah,
twos are
then
100,
2.
50 twos are 100. So 50, ones
Mm.
are 50 and 52 is a 100. So answer would be 2. Here it's 52 is a 100. So it's 1 upon 2, not 2. And that is also not the answer. Now ask me why.
Wait, why?
Because pressure is equals to force upon area. Pressure we have to find. Force is 50. We got 50. Area you will put 100.
Yeah.
When you are taking force in Newton, so you take area into meter in meter square.
Oh, yeah, you have to convert it.
So convert it. Can you convert 100 centimeter square into meter square?
How do I do that?
Now this is your homework assignment. You, who's teaching you maths?
Like in tuition.
Yeah, on Learnivio.
Uh, I don't know his name.
So
Like
his
he'll be little serious. Like, you know.
so you don't know anyone's name.
I mean, I forgot his name, but I only remember when I see their names. I'm bad with names. That's what I'm saying.
Okay, so I'll give the same question for assignment. So you have to find the answer by doing all the conversion, finding the appropriate thing. Okay.
Okay.
So this chapter is completed. From the next turn, we will be starting with the next chapter, the second or the last chapter for physics. Okay. So that you are done with both the chapters, but Rohan, it is your responsibility to do your biology and chemistry chapters.
Yeah.
Okay. Any doubt?
Okay. No.
Hmm. So you must not be knowing my name also.
What?
You must not be knowing my name as well.
No, no. I know your name. Like your name's the like only name I know, honestly. I
Okay.
can remember like I keep names according to like certain words. Like your name's first name is Imdad. Like so I keep it as dad and then